We're going to start this lecture off finishing up a problem which we were doing on a previous lecture, which was number 27, which is actually an assigned homework problem. We just got done with A and B, and we're on C. So just to refresh a little bit here, we're looking at a voltaic cell in which we have iron and silver going through this reaction. We've discussed that iron is the element that is being oxidized and silver is being reduced. And these are the two half reactions that go along with it. For part C, the question is, which electrode is the anode and which is the cathode? Okay. I almost kind of answered this when we were going through here. So based upon what we were discussing here in part A, we can do this pretty easily. So if iron is being oxidized and silver is being reduced, based upon the little trick we talked about earlier, match up the vowels or the consonants, oxidation occurs at the anode and reduction occurs at the cathode. You just have to memorize this or just match up again vowels and consonants and that'll work out fine. It's just a definition-y kind of thing, anodes or cathodes, and what occurs in each one. It's just a name. So we need to put that down here. So just to kind of clarify this, iron is losing electrons, and is the anode, and silver is gaining electrons and is the cathode. Okay, part D. The question as far as what is the charge of these two? So what is the charge? In other words, positive or negative. So the charge of the cathode. So again, you can kind of look at it as far as where electrons are flowing. Electrons are flowing from the anode, and they always will flow to the cathode. So if electrons are attracted to the cathode, that means the cathode is positive. And another easy way I remember this one is the T in cathode sort of looks like a plus sign. And then for the anode, obviously, that has to be the opposite. The anode is negative. E, this question here is a classic question that you would kind of expect to see on an FRQ. Parts of it, some parts, maybe all parts, who knows? But it's a really good question. All these different little parts to it. Last question. Do electrons flow from silver to iron or from iron to silver? Well, I kind of just put that in the drawing right here. So electrons are flowing from iron over to silver. So from iron over to silver. And that one is done. Easy enough. Okay, let's move on over to a homework question. We are on 47. And we're going to need some help from the back of the book, and I just so happen to have some numbers. You may have, if you want to do this on your own, pull up all the reduction potentials for these elements. Boom, 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 boom. I'll scribble them down and then we can talk, but that would be something, if you want to do that, that's helpful. So I'm scribbling these down here. The value for dichromate is positive 1.33. We'll talk about the problem here in just a moment. For hydrogen peroxide, it's 1.776. For copper, I'm going to squeeze this one down here, 0.337. For chlorine, it's 1.353. 9. And for oxygen, it is 1.23. Okay, before I get too far, I'll just go ahead and write these guys down here, and then we can just dig into the problem. For zinc, it is negative 0.763. For iodide, positive 0.536. For tin 2+, negative 0.136. And again, these are all reduction potentials I'm grabbing right out of the back of the book. For hydrogen peroxide, we already had this, 1.766, that's positive. And for aluminum 3+, I believe, it's 1.66. I believe it's supposed to be aluminum. Maybe it's just aluminum metal. No, it should be aluminum 3+, 1.66. So we'll put in here 3+. Its ability to gain electrons. Okay, now looking at these particular elements, we want to arrange them in order of increasing strength as oxidizing agents. So this is a term that maybe you know, maybe you don't know already. An oxidizing agent is something that itself is reduced. It is going to be gaining electrons. So this kind of follows suit exactly as the table lays it out there, as far as all these things are in an order of being reduced. So which one of these is the best at being reduced, acting as an oxidizing agent? So we can pretty much just put them in order from the least positive to the most positive. And of course, I've got the numbers, so at this point, it's pretty easy to put them in order. So again, I'm just going to write this down here. Least positive all the way up to most positive. And that would be over here is the one that has the highest reduction potential. It is the best at gaining electrons. Therefore, it's the most positive, and of course, least positive. Putting them in order based on the numbers we have here. You would have copper 2+, and then oxygen, and then dichromate, and then chlorine, and then lastly, hydrogen peroxide, which is a really good oxidizing agent. So some of these may have known that, produces bubbles, right? Oxygen gas. This is a very good oxidizing agent. Copper metal, or copper ions, excuse me, not so much. Using this one on here is just kind of flipping the idea. Acting as a reducing agent, meaning it itself is being oxidized or losing electrons. So its ability to lose electrons, not so great. So the comparison we're going to have is these guys sitting right here, and we just have to put them in order from, we'll write it down here, just flipping what we did in the previous problem, most positive over to least positive. Now, one of the things that you should want to do on your own is we're pretty good at problem solving and say, okay, I got it, I'm just going to flip them over. But you need to be able to walk away from this and then come back, have one of these particular problems thrown at you, and be able to do it cold. So you're going to have to sit here and stop eventually and make sense of this and understand it, so you could walk in blindly and be thrown one of these problems and understand how to approach and solve this problem. So again, we're putting these in order from the most positive to the least positive, and the order for this, again, is the idea of just flipping it over. We're starting with the most positive values down here and the most least positive, most negative values over there. So the order would be peroxide, iodide, tin, 2+, zinc, and aluminum. And there we have it. That one is done. All right, let's move on over to, it's going to be notes. And I'm just going to get started on this one, and then we'll switch over to a new lecture, but I want to get the beginning part done. So this is kind of a new conversation here, and trying to understand what some of these terms mean. What we've talked about before a little bit is E, or sometimes it's called EMF, which is electromotive force. And of course, we've done some problems with that already. But as far as what it means and what it can reflect, is the spontaneity of a reaction. Spontaneity. This should be sort of familiar because we just got done doing this in the previous chapter, chapter 19, I think it was. And this was looking at the idea or the possibility of a reaction taking place. How likely is it to take place? The equation we're going to kind of focus in on here is delta G minus NF, that's kind of like a cursive F, and E. And under standard conditions, we kind of put these little guys here just to kind of signify that, yep, that's what we're talking about. All right, I'm going to take a pause here and we'll start our new lecture in a moment.